This lesson is on formulas and nomenclature for acids. Okay, so we're going to divide acids up into two categories. And it's all going to depend on whether we have oxygen in the formula or not. So we're going to start out from when we do not have oxygen in the formula. We're going to call those oops, why is this not drawing? We're going to call those non-oxy acids. All right, so non-oxy acids. First of all, the formula begins with H. So we begin with hydrogen. And as the name suggests, there is no oxygen in the, let's call it in the compound. No oxygen in the formula. Okay, so the way we do the naming here is that our name starts with hydro. Then we put in the anion root. And then we end it with ic acid. Okay, it's as easy as that. So let's look at an example, and I'm sure just looking at this formula, you're going to know what the name of this is. So if we have HCl, then to name this, there's no oxygen in the formula. It begins with H. We start out with hydro. Oops, I did something there. Okay, it starts out with hydro. All right, the anion root. So if we look at Cl as an ion, this is the chloride ion. Oops. Oh. This is the first time I'm using this tablet, so I'm kind of spastic, so please be patient. Okay, so this is the chloride ion, Cl minus. So we're going to use the root, the chlor. So this is hydrochlor. That's the anion root. Ic. Oh my goodness sake, keep clicking the wrong thing. Hydrochloric acid. Hydrochloric acid. So we've used that in lab. We're familiar with that, but that is how we do it. And I just want to make a point that if we have HCl gas, as a gas, we would use regular stock system nomenclature. As a gas, this would be hydrogen chloride. Hydrogen chloride gas. But we take that gas and we bubble it through some water, and the hydrogen chloride gas dissolves in the water and it becomes aqueous, AQ. Now is when we call it hydrochloric acid. So for acids, we are assuming for now that they are AQ. All right, so let's do a few more examples. All right, so let's take a look at HCN. All right, so it's our acid, it's beginning with H. CN, this is the cyanide ion. So for our name, we started with hydro. And cyanide becomes cyanic acid. Hydrocyanic acid from the cyanide ion. Let's look at this one, H2S. Now this has a 2 because the sulfide ion is -2, we give our H's a plus charge for acids. So we need 2 H pluses for every 1 S2 minus. For this, hydrogen plus 1, cyanide minus 1, so we only need 1 H in our acid. Okay, so the name of this begins with hydrogen, no oxygen in the formula. This is hydro. And this is the sulfide ion. So this is hydrosulfuric acid. You might think it should be hydrosulfic acid, but for sulfide, we use sulfur hydrosulfuric acid. So you've probably heard of sulfuric acid. That's different. We're going to get to that when we do the oxy acids. So this is hydrosulfuric acids. No oxygen is in the formula. All right, so if we have the name, such as, oops, hydrofluoric acid, and we want to write the formula for that. So hydro, we have an acid, it begins with H. Fluoric, that is from fluoride, so we know that fluoride is F minus, so we only have 1 minus charge, so that means we only need 1 hydrogen. So our formula is just HF. So just like hydrochloric acid is HCl, hydrofluoric acid is HF. Okay, let's look at this one. Hydroselenic acid. All right, so hydro, that's a D. So we know it begins with H. And selenic, that comes from selenide. So if we look on our periodic table, the selenide ion is HSE, 2 minus. So that means we need 2 hydrogens so that our charges will work out. So H2SE is the formula of hydroselenic acid. Okay, so that's it for our non-oxy acids. Now let's look at oxy acids. Okay, so now we're going to do oxy acids. Okay, so for these acids, they will begin with H. Or they will end in COOH. That'll be the organic way to represent the acid. Okay, and obviously our oxy acids have oxygen in the formula. In the formula or in the compound. And that oxygen is in a polyatomic ion. So our oops, I keep hitting this thing on the pen that changes. This oxygen is in the poly. Oops, no, not this. It's in the polyatomic ion. Okay, so one of the things about the oxy acids, they do not begin with hydro. That is only for the non-oxy. Do not begin with hydro. So this is the way it works. We're going to look at the anion. And our anions that end in ite, so our ite anions make us acids and our 8 anions make ic acids. So we have to know our polyatomic ions. All right, so let's look at some examples of this. So if we have HNO3, so begins with H, we've got an acid, we've got oxygen, it's an oxyacid. So we're going to look at this. So NO3, this is our nitrate, ion, which is NO3 minus. So we look at the root of our anion, and then it's an 8 ion, so it makes an ic acid. So this is nitric acid. Nitric acid. Okay, if we have HNO2, then NO2, this is the nitrite ion, NO2 minus. So this is nitrous acid. So 8 makes ic, 8 makes us. All right, let's look at a few more of those. Okay, so if we have H2SO4, so SO4, this is the sulfate ion, SO4, 2 minus, so that's why we have 2 hydrogens. We have to have 2 hydrogens because we have -2. So this is an 8 ion. So this is sulfuric acid. So again, we don't just say sulfic, we say sulfuric acid. So before we saw hydrosulfuric acid when we did not have any oxygens. Now that we have oxygens, it's sulfuric acid. All right, and then if we have H2SO3, SO3 is the sulfite ion. So ite makes us. So this is sulfurous acid. Okay. So now let's go the other way. So if we see carbonic acid, and we want to write the formula for that, then we see that it doesn't begin with hydro. So we know that we have oxygen in it, and we have to find the anion. So carbonic, that ic means our ion ends in 8. So this comes from the carbon 8 ion that we know is CO3 with a 2 minus charge. Since we have 2 minus, that means we need 2 hydrogens, H2, and then our formula for the carbonate ion, CO3. So there's our formula for carbonic acid. Okay, let's do another one. Let's do phosphorus acid. All right, so we look at phosphorus and we see that it's in us. So this means that this comes from the phosphite ion. So that is PO3 with a 3 minus charge. So we're going to need 3 hydrogens here. So H3, PO3. is our formula for that acid. Okay, so now we're going to look at a very common acid. So we're going to look at HC2H3O2, which can be written as CH3COOH. So I mentioned earlier that acids, sometimes they end in COOH. So these two acids are exactly the same. Here we've got 1 hydrogen plus 3, we've got 4 total hydrogens, 2 total carbons, 2 total oxygens. Writing it this way, we still have 4 total hydrogens, 2 total carbons, and 2 total oxygens. All right, so let's name this thing. So it's got oxygen in it, so we've got an oxy acid. So this is coming from the acetate ion. So C2H3O2 minus is acetate. So because it's 8, we have an ic acid. So this is acetic acid. So that's going to be a really important acid when we do AP chemistry. And this is the acid that's in vinegar. Normal household vinegar is about 5% acetic acid. So this is also, over here, this is also acetic acid. But this is written to show the structure of the acid. So we have a carbon that's covalently bonded to 3 hydrogens. Then that carbon is bonded to another carbon. Carbon always likes to bond to carbon. And then the carbon is bonded to 2 oxygens. And one of those oxygens is bonded to a hydrogen. The single oxygen gets a double bond, lone pairs of electrons. And this is our Lewis structure for acetic acid. So here is the H, this H. And then the rest of this is where we get our acetate ion. The rest of this is the C2H3O2. And then there's the H that is the same as this H is the one that attaches to the oxygen. So for right now, I would just say recognize this as acetic acid. Okay? So what I'm going to do now is I'm just going to put up some formulas on some names, and then you could just pause the video and then come back and see if you got the right answer. So here are the ones that you should do. Okay. HBr, H3, PO4, HClO4. Let's do HClO3, HClO2, HClO. Okay, and then, whoops, hydro. Okay, so for these, you're going to write the formula. This one, we've never had this, but I'm going to give you that the okay, give you that information so you can do that. Okay. All right, so try them on your own. Pause the video and then come back and we'll do the answers. Okay, so if you're back, so we look at our first one, HBr, there's no oxygen, so we have a non-oxy acid. It starts with hydro. So this is hydrobromic acid. Here, H3PO4, we have oxygen, we have a polyatomic ion. This ion, PO4 3- is the phosphate ion, so this is phosphoric acid. Here, we've got ClO4. This is the perchlorate ion, so this acid name is perchloric acid. Here, ClO3, this is the chlorate ion, so this acid is chloric acid. Here, ClO2 is the chlorite ion, so this is chlorous acid. And here, ClO is the hypochlorite ion, so this acid is hypochlorous acid. Over on this side, hydroiodic acid, it begins with hydro. We know we don't have polyatomic ions. It's H, iodide is -1, so we only need one hydrogen, Hi. I always think of this as the friendly acid. Okay, for oxalic acid, I gave you that the oxalate ion is C2O4 2-. So to do the ion formula, we're going to need 2 hydrogens to cancel out the -2. And then our oxalate formula is just C2O4. So even if you have ions that you've never seen or heard before, you just follow the rules and it's very simple there. All right, chromic acid. So ek means we are using the chromate ion. So remember, chromate is CrO4 2-. So we're going to need 2 hydrogens and then just our formula for the polyatomic. So H2CrO4, that's it. Hydrofluoric acid, okay, hydro, we don't have a polyatomic ion. Fluoric comes from fluoride, so just HF. And then nitric acid, ek, comes from 8 ions. So we have our H, and then the nitrate ion is NO3. It's -1, so we only need 1 hydrogen. All right, so that's it for formulas and nomenclature for ions.